In this tutorial, we're going to demonstrate how quickly and easily we can create multiples of one set of toolpaths utilizing the Array Copy Toolpath feature. We're also going to take a look at another feature in the software called the Merge Toolpath feature, and that's going to demonstrate how we can merge multiple toolpaths together using the same tool but gain better control over the order in which they are cut. So first of all, we're just going to open an existing file, so I'm just going to go ahead and close this file down, and we're going to go to open an existing file, and through the tutorials folders we're going to navigate our way to the Array Copy and Merging Toolpath guide files, and from the files in the folder we're going to select the Vectric widget Toolpath file. So simply select that and then click open, and this will bring up the Vectric widget, which we've used in multiple examples with our tutorials. And I'll just give you a quick overview of all the layers and the vectors that are on them, and also the toolpaths that are associated to them. So I'm just going to go to the layers drop down here and just going to go through one by one. So you can see the cutout is that particular vector there, slots, then we have the drill holes, we have the text, and then we have the crosshatch, like so. And then if we go over to the Toolpaths tab itself by clicking this arrow icon here, and then you can see we've got a range of toolpaths. Now each one of these toolpaths is associated with vectors on a particular layer. And we've done this by simply, if I just go into one of the toolpaths, we've done this by selecting the vector selection to automatic, and how we've done that is we press the select button here and we specify some of the rules here that are associated with the toolpath and whatever layers that we select from the list here. Like so, so I'll just close those. So if I select each different toolpath, you'll see that the vectors which are associated with that particular toolpath, so you've got the drill holes there, highlighting all the holes, you've got the profile crosshatch, and the profile text, like so. So that's all of the toolpaths that we're dealing with. So let's go ahead and preview them. So let's go into the preview toolpath form, and let's go ahead and preview all the toolpaths. So you can see it's starting with the profile cutout, then moving on to the pocket slots, then the drill holes, then the profile crosshatch, and then last was the Vectric widget text. So that's all of the toolpaths that we're going to be dealing with for this part of the tutorial. So let's go back to the 2D view and close the preview toolpath form. Now let's imagine that we want to create multiples of the Vectric widget. Now there are a few ways that we could actually go ahead and do this, but the easiest way would be to actually utilize the Array Copy Toolpath, which will literally take a selection of toolpaths and array them in a particular grid fashion. Now before I go ahead and actually show you the Array Copy Toolpath, I'm going to go ahead and resize the job. So I'm going to go back over to the Drawing tab and go into the Set Job Dimensions and Origin, like so, and then I'm just going to specify a standard sheet of material, so 96 inches by 48 inches in height, and I'm going to simply press OK to accept that. And then we can go straight back over to the Toolpaths tab. Now the Array Copy Toolpath feature you'll find here right next to the Merge Toolpath feature, and also below the Recalculate All Toolpaths icon. Now all we need to do is simply first of all select all the toolpaths which we want to array copy. So I'm just going to select that icon there, which will highlight all of the toolpaths and make them visible, and then just simply select the Array Copy Toolpath feature. Now you'll notice straight away that all the toolpaths which we have selected here appear now underneath the toolpaths list here. Just to make sure, you can scroll down and you'll see that they are using multiple tools here. So you've got the end mill of 1/4 inch being used in 3 toolpaths, and also a V-bit of 90 degrees and 1/2 inch in diameter. Now what we need to specify first of all, once we've got all of our toolpaths, is the actual grid fashion which we are going to copy these in. So we get to specify the amount of rows we want to create, so that's the amount of rows in Y, and then also the amount of columns, that's the amount of times we want to repeat this in the X-axis. So I'm going to go ahead and specify 5 rows in Y and 11 columns in X. And then we get to choose whether we want to offset these or have a gap in between each of the whole set of toolpaths. Now if we choose the offset option, we need to make sure that whatever values we specify in the X and Y boxes here, we need to make sure that those values are set from the bottom left of our set of toolpaths. So as you can see in the icon here, whatever value in X and Y is going to be taken from the bottom left of the whole set of toolpaths. So if we specify like 1.5 inches here, we're actually going to have overlapping widget vectors. Now if we didn't want that, the easiest way to actually separate them would be to choose the gap option. Now this would be a gap furthest away from the lower left hand corner in X and Y. So in X, for instance, the furthest point would be this side point here, and we'd specify basically a value from this point where the next one in line would start, and again in Y it would be the top part of all of our toolpaths here. So anything above that would be at the moment 1.5 inches above this plane here. So I'm going to leave this as gap, and I'm actually going to keep the X and Y values as 1.5 inches here. And the next option, minimize tool changes, is an option to do with the way we create the toolpath itself. Now by default, the array copy toolpath will run each of the toolpaths to create a single part and then move on to the next one in a linear grid fashion. This means as we have multiple tools being used for our one part, it will require a tool change for every part it starts cutting. Now we are going to need to have a tool changer on our CNC machine or a compatible post processor which will allow a pause while we change our tool manually. Now if it is crucial that we create each part one at a time, maybe because we want to actually get that part off the machine so we can start doing hand finishing, then we do not need to place a check in this checkbox. All we need to do is actually give this toolpath a name. So I'm just going to go ahead and just call this array toolpath and press calculate. And this will bring us back into the preview toolpath form, and you can see that that has created us the array of all of the toolpaths that we've created. And you see that we've only got one set of toolpaths, but you'll see that now it is in a tree fashion. Now at the top of that tree is the array toolpath, and underneath that is each of the individual toolpaths which now have been copied in that array fashion that we specified within the array toolpath. Now in the 2D view, if we go into the 2D view and just turn off the visibility of all the toolpaths, you'll see that we still only have one set of originating vectors, like so. The only thing that we've done is literally get that set of toolpaths which we've created for that one set of vectors and copied it exactly and just offset it 1.5 inches in X and 1.5 inches in Y to create 5 rows and 11 columns. Now if we go ahead and preview this, so if I go back into the 3D view, and I'm just going to slow down the speed here, you'll see that because we didn't check the minimize tool changes, that it's going to do each part one at a time, including the tool change from end mill to the V-bit. So I'm just going to go ahead and preview the array toolpath now. So you'll see that that's doing each part one at a time, including the V-bit. So if I just speed that up, and it'll do that in a nice linear fashion all the way up to the top of the grid that we've arrayed. Now if we wanted to speed that up by not having the tool change for every single part, what we could do is actually just check that option to minimize the tool changes, and then it will go ahead and do all the end mill toolpaths first for each part, and then it will go back and then do all the V-bit toolpaths. So to edit it, all we need to do is simply just highlight the array toolpath, double click it to edit it as you would any other toolpath, and then simply just go ahead and check minimize tool changes and then just recalculate. That's then going to put us back in the preview toolpath form. So all we need to do then is just reset the preview, and then if I just slow it down a little bit and then press preview selected, you'll see that it goes ahead and does all the end mills first and then goes and does all the V-bit toolpaths afterwards. Now once we're happy with array copy toolpath, we just save it out in the same way. So if I go and press close on the preview toolpath form and then just select the array toolpath, go to the save toolpath icon, and then we can go ahead and choose our post processor which is most appropriate for our machine. Now as we're using multiple tools, we are going to need to use a post processor, as I mentioned, with an automatic tool changer or a post processor that is compatible and enables us to actually pause the toolpath while we change the tool. Then we just go ahead and then save that out as we would do normally. So we just give that a name, and then we'll just be running that one singular toolpath on our CNC machine. So once we've done that, it's going to close the save toolpath form. Now if we needed to make any edits to these particular toolpaths, we can actually go ahead and actually just edit the vectors as they were, and then we just actually update the individual toolpaths themselves, as in reality they still only ever represent just those particular vectors. So whatever we update here in the vectors or in the actual toolpath will be arrayed as it's still underneath the actual array toolpath itself. So if we just turn that on, and let's imagine that we wanted to update the profile cutout pass, we can actually still do that. So you just double click in it in the same way. We change one of the parameters, maybe the tool for instance, or maybe the actual cut depth. Maybe we wanted to go slightly below the actual material just to make sure that we did cut all the way through. So let's imagine we just take this to 0.4 like so, come down, press calculate, and then it will give us the warning it's going to cut through the material. Press OK, and we can actually still get all of those toolpaths, and it would have updated all of the toolpaths for every single part. Now another thing that we may want to do is actually obtain our original toolpaths back. Maybe we don't actually want to create an array copy toolpath anymore. So the way we would actually obtain the original toolpaths is actually to delete the parent of all of these, which is the array toolpath itself. So you press the right mouse button over the highlighted array toolpath, go to press delete, delete this. You will get an option to actually keep the original toolpaths, and then you would say yes, you do want to keep those original toolpaths, and then it will remove the array toolpath from that, and you'll get all of the toolpaths back as one singular part. And then next we're going to use an example where we can demonstrate the benefits of the merge toolpaths feature. Now this is where we again create multiple toolpaths, and we will end up with one singular file to run on our CNC machine. But it differs from the array copy toolpath as it doesn't create multiples of a particular set of toolpaths. Instead, it allows you to merge together a bunch of toolpaths and gives you control over the way you cut them on a CNC machine. Now we are able to replicate what we achieved here with the array copy toolpath, but we would have had to first create multiple copies of the vectors, then created all the toolpaths for those vectors, and then we could then have used the merge toolpath feature to control the way it was run. Now the array copy toolpath is much quicker at replicating a part in a grid style fashion. However, the merge toolpath is better at handling multiple parts, the likes that benefit from using nesting, for instance, like cabinet parts. So in the next part of this tutorial we're going to work with some nested cabinets. So I'm going to go to File and Open, and from the Files folder I'm going to select the nestedcabinets.crv and then press Open. Now when it asks to save the changes, you can if you wish. I'm just going to decline and press No, and you'll see that we have already imported a load of vectors from an external cabinet making program, and what I've done is I've nested them into separate sheets, and you'll see that we have all the layers here for the different type of vectors that are in our cabinets. And then if I go over to the drawing tab, to the toolpaths tab, sorry, you'll see now all of the toolpaths that we have. Now each one of these is using the same tool. They're all using a 1/4 inch end mill, but there are different types of toolpaths. So we've got hinge holes, shelf holes, drawer holes, and as you can see we've got profiling and then pocketing, different types of toolpaths there. So to give you an idea of what the cabinets look like when they're toolpath, I'm going to go ahead and first of all select sheet 3. Now how I do this is I'm just double clicking over one of the sheets, and it will then make that the selected sheet. Now we can just zoom in so we can see all of the vectors there. So you can see we've got a few cabinet parts there, and if we go to recalculate all, so for every time we select a different sheet, if we press recalculate, that should then recalculate the toolpaths for these particular vectors, as these toolpaths are all wired to pick up vectors on particular layers on the current sheet. So recalculate, and you'll notice that it says it's recalculated all the toolpaths correctly, and you can see that overlaid on the 2D view. And then if we go to the preview toolpath form, we can go ahead and preview all the toolpaths like so. And you can see that's running them in the order that they're presented here. So it would have started off with all the holes, then the profiles, then the pocketing, and then the cutout pass, like so. Now when we're creating parts like this, it would actually be more efficient if we could actually have some control over the way those toolpaths were created. So for instance, I may want to run all the toolpaths for this part, then this part, so then I can actually start taking off parts from the sheet to actually start finishing them, or even putting them onto the next stage before that we actually go ahead and sell them. And this is where the Merge Toolpaths feature really comes in. So if I go ahead and close the Preview Toolpaths form here, and then I'll just go into the Merge Toolpath, which is next to the Array Copy Toolpath, you'll see. And this will bring up the form, and it will say toolpaths to be merged. So basically we need to have at least 2 toolpaths to create a merged toolpath. Now here we've got quite a few, so all I need to actually do is just select the top icon there, check that, and that'll make sure all the toolpaths are visible. And you'll see that those have now all appeared in the toolpaths to be merged list. So once we've got all the toolpaths that we want to merge together as one file, we can then actually start thinking about the way we actually want to order those toolpaths, and that's in the next section here. So basically we can select one or more ordering approaches to try and actually achieve the fastest method to actually machine them, or we have an option as well to actually merge them by part. So as I was mentioning earlier, we could actually go ahead and create all the toolpaths for this particular part, and then move on to all the toolpaths for this particular part, and then this part, so that we can actually start taking those parts off the CNC while the rest of the parts are still being machined. That way we can start that finishing process much sooner. If we didn't want to create them by part, we can actually still choose the ordering, and the software, depending on what options we choose, will carry out the toolpath in that particular method. So to begin with, I'm just going to show you what the software will come up with if we don't do them by part. So I'm just going to take off the option to merge by part, and if I select all of the options, so we've got left to right, so that will go from the left hand side of the sheet and it will go to the right hand side. The grid will go in a grid fashion similar to the Array Copy toolpath. Bottom to top, we'll do all the parts from the bottom going upwards, and the shortest path, we'll literally just try and find the shortest path between all of the actual toolpaths themselves. Now if we have all of the options available, the software will choose which one of those is actually the fastest. So to begin with, I'm going to go ahead and let the software choose the fastest method out of all the 4 options that we've chosen. So I'm just going to give this a name called Merge Toolpath. I'm going to hit the Merge Toolpath button. It's going to go ahead and give me a warning that says basically the resulting merge toolpath will not necessarily preserve the current toolpath order or cutting order within an existing toolpath. Once we understand that that is the case, we can simply press OK, and this will bring us into the Preview Toolpath form. So we can go ahead and reset the preview and make sure that the merge toolpath is selected, and we can go ahead and preview that. And I'm just going to slow this down just a little just so we can see what that's doing. So this is the method that the software has chosen to be the fastest way to actually machine all of those parts. Now not only should this be faster because of the way that the software has chosen to actually toolpath each of the individual toolpaths themselves, but it should also be quicker because instead of running each of the toolpaths individually as we would have done previously, the actual tool would have had to have gone back to the X0, Y0 before it then starts another toolpath. So we're saving on a lot of time here where the machine isn't having to traverse from one toolpath back to the X0, Y0 and then back out onto the sheet to toolpath another one of the toolpaths that we have to run next. So by just simply creating a merged toolpath, we can save off quite a bit of time. Now where the merge toolpath feature really comes into its own is where we can actually have the ability to merge by part. So we can actually create the merge toolpath on a merge by part basis. So we can actually go ahead and create all the toolpaths for this particular part, then this part, then this part, or in an order which we can specify within the merge toolpath. Now this is very handy. Obviously, as we say, we can get those parts off the machine sooner so we can start the finishing process a lot quicker as well. And that is one of the best ways that we can save time, as we haven't actually got to wait until all of the toolpaths are finished to actually get the parts off that machine. So let's close the Preview Toolpath form and let's create a new Merge Toolpath. So let's go back into the Merge Toolpath form And let's select all of the toolpaths. I'm just going to deselect the merged toolpath at the bottom there. And then what we're going to do is we're going to select our ordering. So make sure that the merge by part is selected. And then what we can do is we can start selecting any of the orders. So what we'll do is we'll demonstrate each one at a time. So first of all, I'm going to show you left to right. So that should create these parts first in this sort of fashion. So let's just call this merge toolpath left to right, like so, and press to create. Let's go into the preview toolpath form and then preview that. So let's make sure that we reset the preview first. And there we go. So we can see that it's doing it left to right there. Can just speed that up as well. And it's doing each of the parts all at once. So again, let's go and create the next one. So again, highlight all the toolpaths. Let's deselect those merged ones, and then we can do the grid style fashion next. And just call that grid, like so. And just go into preview toolpaths, reset, and preview. So I didn't actually get to see what that was like. That was too quick, so I'm just going to go ahead and preview that again. So that's just doing it in a grid fashion, like so. Press close, and then we can go from bottom to top. So just deselect all those that we don't need in that merge toolpath. Deselect grid, select bottom to top. Just call this bottom to top, like so. Create to merge, and let's preview that now. So you can see it's doing all the toolpaths at the bottom first and then heading on to the parts at the top, like so. And then we got the shortest method. So let's go back into the merge toolpath one last time, just deselect again, and then we can just select the shortest path. So I'm just going to call this shortest, like so. Then we can reset and preview that. So that was very similar, actually. The fastest method was the closest to the left to right ordering system, so that actually would be the fastest method to toolpath these particular parts on this particular sheet. Now it will be different, obviously, for each different sheet that we're going to toolpath. It all depends on whereabouts all the parts are and the distance between all the toolpaths. So if it was just speed that we actually were concerned about, we could just make sure that we leave it on the shortest option all the time, and then that will always ensure that we are getting the parts cut at the fastest possible speed. If it's actually the ordering which is most important to us, just make sure that we have whatever is most preferential to our CNC machine selected. And then once you've gone ahead and created the toolpath, you can go ahead and save those in exactly the same method. So as the merge toolpaths only enable you to actually combine toolpaths that use the same tool, we won't have any issues here where you have to have an automatic tool changer or a specific post processor that enables you to pause, so you can actually change the tool manually mid toolpath. So again, you just select it, you go to the save toolpaths icon, and you'll see that will be highlighted underneath the toolpaths to be saved, shows you the tool that it's using, and you simply just go ahead and select the post processor most appropriate for your machine, and then save it out, like so. So just to recap what we've demonstrated in this tutorial, we have learned if we have a single part which we would quickly and easily like to create multiple copies of, and having them set out in a grid fashion works with the shape of the part we are wanting to cut, and saving as much material as possible isn't really an issue, then the array copy toolpath would be the nicest solution. If we would like more control over the toolpaths, whether we're cutting a singular part or a multi-part design like our nested cabinets example, then we can achieve that with a bit of extra work up front, where we would have to organise our vectors and toolpaths for all of our parts first, and then utilise the ordering system of the merged toolpath to gain extra control over the way they are run, whether it be for pure speed or the fact we want to have our CNC finish the toolpaths for whole parts before moving on. The choices are there for us to make. And with that concludes this tutorial, so thank you very much for watching.